Hello, welcome again. In this lecture, I'm going to explore what is the role of stemming in NLP, what are basics of stemming, what are the errors that could occur in stemming. Let's see one by one. Before dive into the Python implementation, let's explore what is the meaning of stemming here. In the pre-processing standardization the text, one option for this is stemming, where words are reduced to their base form. For example, words like connecting or connected will be stemming to the base word connect. Stemming words like removing suffix and ending of word, but can sometimes lead to the base form not being meaningful because they are just chopped out, or a proper word. We standardize the text in this way because it will lower the number of unique words in our data set, therefore reducing the size and complexity of our data. Removing complexity and noise from the data is an important step for preparing our data properly for machine learning, deep learning, ChatGPT or OpenAI. So we will be using these algorithms, for example Llama and OpenAI, but once we must finish these pre-process steps here. Let's see what are these stemmings here. In this figure, you can see this changing, changed and change. Everything is just chopped out to the change here. But this meaning is just literally diminished here. Which means we can not say that this is the proper word we are going to explore. Let's go back down here. Here in this example also, you can see this word is having so many other suffix and prefix: changes, changing, changed, changer and change. Everything is just chopped up or literal meaning to the change here, which is literal process of stemming here. Now go back to the Python implementation, how we can implement this same technology inside the Python. For this, I'll have to first import the library which is used for this stemming. This library called lntk.stem. I'm going to import porter stemmer. This is kind of algorithm or kind of library which is used for stemming. So I'm going to use this porter stemmer inside this LLTK. I'm going to create a variable for this same porter stemmer, same function. Just create this one. Now let's have some set of words here. Those are kind of connecting, connected, connectivity, connect and connect. Let's see how they are going to step here. Let's deploy this for loop over the set of list. Here I'm going to deploy this connect underscore tokens, and this is ps.stem.t. So ps is porter stemmer. I just implemented over my stemming keyword here. Okay, this is the function which I just deployed here. Can you see? Okay, maybe I didn't run this code. Okay, now can you see? This is now connecting, connect, connected, connect, connectivity. Every word is just reduced to their relevant stem. They just chopped out here. Let's see another example here. I'm going to create a learn token which is having learned, learning, learn, learns, learner and learners. Let's deploy the same function stems over the given set of list. And here I'm going to use this ps porter stemmer and deploy this for loop. Can you see? This is showing learn. Everything is just chopped into the original sentence. But can you see the last keyword? Learner and learners. They are not chopped blindly. So we have the same output as learners as well. Let's see another example like other tokens. For example, we have the likes, better and worse. Let's define this variable. Let's apply the same for loop using the stem function, and let's print this keyword. Can you see? This is just like, better and worse. The words is just chopped out and showing this words, which is literally illogical meaning. So in upcoming session, how we can overcome this drawback, which is not showing very logical meaning, and we can see the alternate solution of this problem. But before this, let's see what are the errors that could occur using the stemmers. We have seen sometimes understemming is also there. Understemming is the opposite of overstemming, where words that should be produced to the same root word from are not. This can introduce unnecessary complexity into feature set and hinder the effectiveness of text analytics algorithm. Let's take an example, alumnus. The different forms of this will reduce into alumni, alumna, alumni, and we will get the output of alumnus. It should be noted that English word has a Latin morphology and these synonyms are not combined together. Let's see overstemming. So overstemming happens when words that should be stems into different root from are incorrectly stems from the same root. This can lead to significantly loss of meaning, impact the accuracy of text and for example, university, universal, universe, and this is reducing to universe. For example, this is deployed over these different words. Here in this case, even though these three words are etymological related, their meanings are completely different, but they are chopped into a single same sentence here. This is called overstemming. Here we have understemming, where we are reducing to the same root from the same word, and here we are giving this different meaning to chopping into a same meaning. This is how we can implement for the several process. What we have learned in this section, we have learned stemming process. Let's see what are the other topics in NLP. Thank you so much for joining this session. Let's see in the next video.